order to complete that lab. How to get started in a project, how to find out how a project works, how to understand, how to navigate its website, etc. And hopefully this will make a lot more sense now you've actually tried to do these things with the A2PS project. Then we'll be looking at a particular example in this lecture at the end, the Video LAN project, also known as VLC. We'll be looking at that in some detail, how it's organised, how its website is organised, etc. So, as before, please ask questions as I'm going along. I very much want these lectures to be interactive with all of you, so if you want to divert the lecture down some particular path or ask questions about any of the lab materials, that's absolutely fine. Please just raise your hand and we can discuss in detail any of the lab material or other aspects of the course. Okay, so researching the project. So let's say you've chosen some project you want to work on. The idea is to find out, how do you find out more about the project and what sort of information do you need to know, right? What are the key aspects of a free software project that are the vital statistics of a free software project that you need to know in order to be able to contribute to the project? Common source of information. Most projects have a manual page or some sort of documentation. If you're not familiar with manual pages on Unix systems, you get the manual page using the command man. So for example, on this system, I would type man A2PS, and it would tell me how to use the A2PS system. So that's MAN followed by the name of the command. You can also search in your manuals for something, a keyword that might be related. So you want to manipulate something to do with PostScript. You can man -k PostScript means look for a keyword PostScript in all the man pages, and it shows you all of the different commands that have something to do with PostScript, right? And you can see one of them there is A2PS. Okay, it manipulates PostScript, it generates PostScript in fact. So very useful, the man command. So man is mostly for things once they're already installed. When you're trying to investigate a new project and it's not necessarily installed in your system, you usually get the documentation from somewhere else. And where's the most common source? Where would you normally get the documentation for a new project you haven't got installed? Any guesses? Website. That's right, the obvious place. Look on the website. How do you find the website? Do a Google search. Right, so if we've got ourselves here, I will just do a Google search for A2PS, and there you go, it comes up with a home page for the project, right? And what you met in this lab is that there's a little bit of confusion because it says that more detailed information is available on that site, right there, that site there, and some of you went there and discovered in fact it had an old version. And in fact the newest version was on the Savannah, which is part of the GNU site, right, which is where this one is directing you away from. So the correct destination was in fact back where you came from, okay? Now that, it does take a while with a new free software project to get used to some of these things. And one of the problems with this course is we're trying to fast track you. We're trying to get you through this sort of thing on projects very, very quickly. Usually you would have plenty of time to, several weekends or whatever to investigate a project, start learning about it before you start trying to get deeply involved in the project. In this course, this intensive course, we're trying to get through those things much more rapidly. But what I'm trying to do in the lab, and in particular that last lab, is give you some of an idea of the types of issues you will tend to run into, so hopefully you know the types of solutions you might be able to find. And one of the issues you'll find is that the websites for projects may not provide accurate information on where to get the latest version, or what their source code management system is, or how to build the project, etc. You often have to work that sort of stuff out for yourself, or by looking up with Google, finding other people have asked the same question, or just doing a bit of reading of what's available, poking around a bit, delving into it to eventually find the right answer. That's quite common. Okay. So back to the lecture. You can also get a lot of useful information out of the binary package description. If the package you've got is already available for your operating system, right? So in this case, A2PS is available for Ubuntu. You can install it without having to do anything else. Yeah? Right. So A2PS is available for Ubuntu, which means that the binary package itself contains a lot of vital statistics on the project. How do you think you access that? Any ideas? Several different ways. How do you find out the information about the project from the binary package. Okay, well, what do you think what's your first guess?
Well, he's looking for some sort of readable document inside there.
Yeah, and there probably is a document. There's actually a simpler place to start. The package manager itself, if you go to the administration Synaptic Package Manager, and of course different operating systems use the different package managers. Debian Ubuntu uses this thing called apt, and it has a graphical user interface, has multiple graphical user interfaces. The particular one we're using in this lab is called Synaptic, right? So inside this little package manager, what do you think you would do to find out information about A2PS? Search for it, right? Search for A2PS. Okay, find the project, and then we can go right-click on it and go Properties. Right, and this gives us a whole lot of information. We've got a description, right, that describes what the project does. We can get this whether or not we've installed the package. We've got the various versions, right, shows what version we needed to install, which would have answered some of your questions that you hit where you wondered, am I downloading the right version, right? If the one that's packaged is a later version than what you're downloading from the website must be out of date. You're on the wrong website, okay?
Ubuntu's package versioning numbering convention is a little confusing because it's Ubuntu-esque.
Yes, right. That's exactly right. There is some issues with the packaging. Sorry, Michael. With the packaging, Ubuntu can sometimes renumber packages a little bit. Most of the distros do this to some extent, but in this particular case, it's fairly clear. This is 1.41. This is version 4.14. Well, okay. Debian puts this prefix, 1 colon, right, at the front. The actual version number of the upstream package is 4.14, and yes, that is quite confusing. If you go and have a look on the site, you'll find in version 4.13. In fact, I think 4.13b we discovered was released in 2000, 9 years ago, and 4.14 was released in 2007. What does that tell you about the project?
It's not active.
It's not being developed particularly fast, unless there was a C, D, E, F sort of versions, 4.13, which there probably wasn't. It's not a very active project.
At the tail end of the README, the main developer's declaring that there are no bugs, so it doesn't need to be...
Right, yes, that's one of those things thrown down the gauntlet. Yes, there are bugs. In fact, you look at the bug tracking system for things like Ubuntu and Debian, there are bugs for AWS showing up. Okay, installed files, it shows what files it installs. There's all the various files that when you install it, that's what you'll end up with, right? And it includes some documentation. If we look under user share man, user share info, various documentation there, and there's also a user share doc, I think. There's various documentation that's thrown in here apart from the basic package. Dependencies. This is, remember some of you struggled with getting the right dependencies installed. This binary package manager tells us what the dependencies are. Now, are these the dependencies you need to build the package?
No.
No? Why not? What are these then?
These are what users can use when it's running.
Right, so there's a difference between build dependencies and runtime dependencies. A package can depend upon a particular library, then usually in order to run, right, it needs that library installed in order to run, but there might be a different package that it needs in order to build. Often the difference between the two is a /dev suffix. You end up with something like you need the boost package called libboost and to run it, but then you might need libboost-dev to compile it, the development version of that. And there also are usually extra tools that are needed to build it. For example, most projects written in C need what in order to build them?
GCC.
Right, a C compiler, GCC, usually some sort of C compiler, and the one that's usually used on free software systems is called GCC. And so there is a build dependency upon something called GCC, which might even be a chain of dependencies. It might be just, C development type package that you need, and GCC is one component of that. Okay, so there's build dependencies and runtime dependencies. And then there's the various common information which just provides, it says that it's an optional package, it's not essential, that it's in the word processing section of the universe, which is a particular categorization within Ubuntu, and how big it is, etc., the latest version available. So all of that you can get out of this package manager. You can also all get that from the command line as well. You can get all the same information by typing the appropriate apt command on the command line. If you're not familiar with apt already, you probably find it easier to use this binary package manager to find out dependencies and things that you for a particular package. Okay, so that's one way you investigate a package.
Who
Yeah.
maintains the package manager?
The package,
Keeps up to
well,
date
it's,
and so on.
the maintains the data in the package manager or
Yeah.
the package manager itself?
Well, the data in the package manager and that it's pointing to the right files and the latest files and all
Right,
that sort of
right.
thing.
Within each distribution, so the Ubuntu distribution, there is a maintainer for each package. So there's 9,000 odd packages. Now the Ubuntu distribution is derived from and closely allied with the Debian distribution. So in fact, most of the packages come directly from the Debian distribution, and there is somebody whose job it is to maintain A2PS within the Debian system. And that person, the packager or maintainer, the packager has to put together the package. He has to construct all the various pieces from the upstream. It's also their job to watch for new releases, which isn't a very onerous job in the case of A2PS, right? Only one every few years. They have to watch for new releases. They have to also make sure that it builds, because there might be a change in the underlying operating system that makes A2PS not work at some future time. They also have to follow bug reports, etc. So to become a Debian or Ubuntu maintainer, it actually is a fairly strict process. We have to demonstrate your competence in all sorts of areas, understanding of the Debian free software guidelines, understanding of the rules and norms of how to maintain a package. But there will be somebody whose job it is to do that. They then supply that package into the Debian or Ubuntu system, and it's then included in the CDs and DVDs, etc., that are distributed. So it's very much itself a community distributed effort. If you wanted to look after a package, if there was currently a package, a free software package that wasn't in Ubuntu, and you wanted it to be in Ubuntu, you could volunteer to be the person who puts it in and be in charge of keeping it all up to date, etc. And you'll have to go through jump through a few hoops to do that, to prove that you've got the competence to do it. But anyone in the world can do that, can contribute the package. There are some other Linux distributions or free software distributions that have different policies. So for example, the Red Hat Enterprise Linux, right? That's a distribution that is far more commercially oriented, and they have, it's employees of Red Hat that tend to maintain the packages and be in charge of what goes in, although they derive a lot of what they have from a non-commercial distribution called Fedora, which is a related distribution that has a lot of common packages. And it's the stewardship of Fedora is under the same company, Red Hat, who does Red Hat Enterprise Linux. So one distinction that's quite important to make is that the people who write the software very often aren't the people who maintain the package. So for example, I'm the author of a number of free software packages, Ccache, Samba, a few other packages like that. Those packages, although I write the software or I contribute to the software among many other people, I'm not the one who packages that software for the various distributions. Why not? Why don't I package it for all the distributions?
Well, haven't you done enough?
Well, how many distributions are there, do you think?
Heaps.
How big are heaps?
Hundreds. if you wanna go.
Tens, hundreds,
Hundreds,
thousands?
Hundreds of
Yeah.
thousands.
Yeah, hundreds of distributions. There are hundreds of free software operating system distributions, right? Now there's only a dozen or so that are moderately popular, that are widely used, but there are hundreds in total. So if I wanted to make sure that I offered a package for every distribution, I would have to do hundreds of lots of work, plus I would have to be familiar with all those hundreds of distributions to know that I'm doing it right, because you might have to do it differently on different distributions. Okay, so it's an awful lot of work. Now some projects, including some of the projects I get involved with, like for example the Samba project, does offer binary packages for specific distros, the most popular ones. For example, we do offer Red Hat and Ubuntu and Debian packages up on samba.org, right? But that isn't done by myself, that's done by another volunteer for the Samba project that volunteers to package that program for these various popular distributions as a service to the community. It tends to be that the larger and more complex the project, the more you spread out the work across multiple people. So you tend to find that there's somebody who's in charge of packaging in larger projects, whereas a small 1 or 2 person project, they do everything, and they might create packages even for half a dozen distros. But then each of those distros then has the responsibility of the hundreds of distros of making sure that their key packages are packaged correctly. Very often what they do is they grab somebody else's package. So even though these distributions are in some ways competing, they steal from each other all the time, and that's encouraged. That's part of the free software ethos, to build on each other's work. So you do find that one distribution just, if it thinks that its package is going to be very similar to some other distros, it will just grab that one and import it. And that's absolutely fine. That's within the ethos of the free software community. Okay. So, back to somewhere here. So, common source of information, a web search, freshmeat.net, you can find out a lot of information. A lot of packages, but not all, certainly the most popular packages tend to be registered on freshmeat.net. Have all of you had a look on freshmeat.net in the last week or so? Anyone not had a look at that? Anyone? Okay. Very useful website. It contains a registration of a large proportion of free software packages. Not all, but a large proportion. And in particular, it allows you to register your email address to get notified when a new release happens. If you've got some particular package that is very important for what you do, if you're, say, an artist and you use the GIMP a lot, or if you're a writer and you use OpenOffice a lot, you can register and say, let me know when there's an update, and search for them when there's new versions of various packages. Now, that's a very useful service, and the announcements on FreshMeat tend to tell you what is new about the new release. So it's a very useful site. There are other sites that have the same aim. One of the things in the free software world is there usually tends to be more than one version of everything. There's more than one distribution, there's more than one editor, there's more than one compiler, there's more than one of everything. Why is that? Why do you think there are 10 competing editors or 1,000 competing editors, or however many there are?
Some people value certain aspects of them more than others.
Right, people have different priorities. Somebody comes along and says, I can do better than that, right? And maybe they can. Remember there was a survey at one stage, I think, of students entering MIT, and they were asked, where they thought they'd come in the class, and something like 95% of the students thought they'd come in the top half of the class. Everyone thinks they're good, right? Well, the same is true in the free software community. People tend to be confident of their own abilities, and very often they think, I can do something better than that, and they try. And of course what tends to happen is then one project builds on another. They take all the ideas from the earlier one and build another project, which might be similar, but then the earlier project sees their idea and grabs stuff back again. And that's good, that's encouraged, right? Grabbing stuff from other projects and incorporating it is all part of the free software ethos. The hoarding of it, say, you can't grab the stuff that I've done, that's not fair. That sometimes happens, but it's unusual. And it's a bit jarring in the free software community when it does happen. Okay? It does happen though. Some people get very personally attached and don't want anyone else to use it. Usually what happens next is they leave the free software community and make it proprietary instead, because that might suit them better. Right, key project attributes. Okay, these are, there's lots of different attributes of free software projects. These are the ones that I think are sort of essential to know about a project before starting to get involved, right? Now, how you find out each of these varies by project. Often you can answer all of them just from the project's website, if it has a website, or from its documentation. So let's have a look at what some of these key attributes are. Who does the development? Is it a one-person project? Is it a great big team? Is it a company putting out free software releases? Who does it? Who is the people actually doing the work? Who are they? Why do they do it? How is it organised? Is it organised? Is it just disorganised? Right? A lot of free software projects, it's really a stretch to even call them organised at all. Other ones are extremely well organised and have weekly conference calls and meetings, and they have a strict hierarchy and steering committees and voting systems. Some of them are very well organised. Others are extremely disorganised. How is that structured? And I've got a lecture later on project governance that goes through the different ways of governing a free software project and the various flavours that are involved. And it isn't just that the big projects are more organised and more governed. Some of the very large projects are more like an anarchy, and some of the smaller projects are very well organised. It just depends on the particular flavour that the person who started the project wants. The project original developers tend to set the stage for later developments in the project. How is it licensed? What type of license does it use? Is it a FOSS license for a start? If it's not, then it's not really relevant to this course. Does it use a GPL license or a BSD license or some other variant of the license? That's important because you may have, when you contribute, you may want to know that you can then use those contributions elsewhere, or you may want to know that they can't be used in proprietary software, what license you're releasing your contributions under matters for what can happen to those contributions further down the track. How are stable releases done? Has the project ever done any stable releases? Right? Some projects have never done a stable release. Some projects have done stable releases, but they won't admit it. Anyone think of an example?
Google.
Right, beta, Google beta, okay, beta tags. But a lot of free software projects as well, they tend to get stuck at version 0.99 point and then some great long number. Right? Wine was stuck like that for a very, very long time. Everyone else thought it was a stable release. It was great, but the developers themselves weren't satisfied, and they didn't want to call it 1.0. So they called it 0.99, whatever, and you get the yet longer and longer version numbers. And this happens in every project. We got stuck on the 1.6 series in Samba, right? We've got 1.6.0, 1.02, 1.03, and we went through years of development where we said, hey, there is a 7 there we could use. Right? Let's go to 1.7. We skipped that and went 1.8 in fact. So version numbering can be a bit strange that way, but how are the stable releases done? The policies for stable releases differ widely between projects. When I'm the release manager for a project, I tend to follow a particular rule for choosing when to do a stable release. And that rule is this. If a new user were to come to this project now, so a new person downloading it, would I be recommending what's in my development tree, or would I recommend the last release? If I would feel that a new user would be best served by using what's in my development tree, it's time for a release. If, however, the release is so bad, the current development tree is so bad that a new user would just get confused or doesn't have the documentation or whatever, then it's not time for a release. Now that's a very different standard to other people. Even within the Samba project that I work on, other people have other standards, right? Some people take the attitude that you do a new release when you would recommend everyone who's currently using it to upgrade. Other people, which is subtly different, right? It's different from a new user. Other people say we only do a new release when there are no regressions. When the new release, doesn't have anything that is worse than the last one, right? Which is, again, a different standard, okay? Now, some of these different standards, sometimes they lead to very fast series of releases, right? How quickly do you think some free software projects are released?
Slowly.
Yeah, how long between releases?
Maybe it was a couple of years.
Can be years. Okay, let me bring up the changelog for Samba when I was doing early versions, right? When I was starting off the Samba project, I'll bring up the changelog for the old versions, say here, and look at the changelog. Now, look at the dates for the different releases, right? These are full releases. So, first 2 releases on the same day, okay? Next release the next day, another release the next day, another release the next day, 3 releases on the next day, then on the 4th I had a holiday, right? No releases that day, okay? So for the first few years, I was doing releases of the order every few days, right? Sometimes several releases in one day, okay? This is rapid development, right? Now that tends not to happen once a project is older. Younger projects often have very, very fast releases. Why is that?
There's more to do.
There's more to do, yes, but it's not just that.
There's a lower user base, so it's not affecting many people to release more.
That's very true. One of the big reasons people hold off releases is they're afraid of hurting existing installs. When there's a small user base, and when you know them all personally, because you met them on the mailing list, you're less afraid of that, right? Plus, it tends to be the excitement of a new project. You get really enthused when you just start a new project, and you're sort of working day and night on this thing, and you get some new feature, and push it out. Wow, that new feature, isn't that great? Right? Whereas after 12 years working on the project, it's not quite so exciting when a new feature gets added. Right? So things tend to slow down. Older projects tend to have longer times between releases. Okay? Some projects keep up the very, very fast releases. The Linux kernel kept up very fast releases for a long time, but it's slowed down now. It's moved down to a few months, whereas Linux was doing multiple releases in a day at some points. But there's not many projects that are quite as fast released as Samba was when I was first doing it. Anyone know why that was, what I was doing particularly fast? Because I was a PhD student. I was trying to avoid writing a thesis. Procrastination.
Procrastineering.
Right? Procrastinating, indeed. Procrastination is one of the great driving forces of the free software community. Without procrastinating students, we wouldn't have a lot of the free software that you use every day. Okay? Yep, another one, right? You should be off writing your thesis. And instead, you're sitting here in this course procrastinating. Right? What I'd like to see is constructive procrastination, where while you're procrastinating, you actually generate something useful. So as a result, I think I started about 25 new free software projects during the 8 years of my thesis, which was a little extreme. Anyway, so how a stable release is done, different projects have different attitudes. Look at how fast they're done, try to work out what criteria they use to choose their stable release, right? When do they do one and why? Okay. What communications methods are used? There's a huge variety of communications methods available. What are the most common ones in the free software community?
IRC.
IRC, yes, that's one. There's something even more common than that.
Mailing lists.
Mailing lists, right? Mailing lists are the most common. Okay, and then IRC, what else is there? Sorry? Farms, sorry?
Forums.
Forums, yes, web forums, like we use our little discussion forum. Yep, indeed, any others?
Usenet.
Usenet News, yes, in the early days in particular. Usenet News was extremely, still is for some projects, the core of some projects, though it's less popular now as a communication medium for free software projects. Mailing lists tend to have taken over. Although it's getting a bit of a resurgence because for some reason the spammers are now leaving Usenet alone.
Seems to be getting resurgence for binary files as well.
Well, yes, also for binary files, yes. Which aren't necessarily free software. Yep. So what other forms of communication are there?
Conferences.
Conferences, indeed, very important, right? They're often combined. So there's projects, you can say there's one of the stages of the growing up of a project, getting to a certain size, is when the project gets its own conference. And it really has got to a fairly large size when it has multiple conferences that even compete with each other for the one project, right? There's only a few free software projects that have got to that point, but there are some. And so there's like an annual conference or a biannual or even monthly conferences for some projects. Okay, what else is there? How else do people communicate?
Websites.
Websites, yes. Yeah, there's other things? Twitter, yeah. There's another one, phone calls. Some projects actually use conference calls, use phone calls. Why is that not a popular mechanism in the free software world?
It's not as open as the other.
It's not as open, it's more exclusionary. Only people who know the right time, they have to be in the right time zone. After that, you get up at 4 in the morning, right? In Australia in particular. You have to be in the right time zone. And you have to also have, have a phone that you can ring internationally, and you can only have a certain number of people on the phone call. You can't have thousands of people on the one phone call without it being complete chaos. Or you have to have sort of mute buttons and all that sort of thing. But some projects are based on phone calls. Now think about the proprietary software world. How many of you have been involved in proprietary software development? A few? Okay. What were the most common communication mechanisms? Meetings? Face-to-face meetings? Yeah. And phone calls perhaps? Yeah. So in the proprietary software world, it tends to be phone calls, face-to-face meetings, water cooler conversations, that sort of thing. In the free software world, it tends to be mailing lists. The reason why the free software world chooses these more open mechanisms is basically geography, right? If you get a whole lot of free software developers for one project in the same room, they will tend to use the water cooler discussions. If they're in the same office, they'll often use, or the same city, they'll ring each other and things. But the geography of the contributors pushes it down the line of more open communication, which also means that it's easier for more people to be able to contribute. And that's one of the reasons why you get more people contributing to free software projects than proprietary ones, apart from the fact that proprietary ones usually don't welcome external contributions. But even within a company, right, you may find this as sort of a clique for the proprietary one, it's more open to free software development. Okay, how are bugs tracked? Right, this is one of the things you need to find out. If you want to submit a bug, where do you submit the bug? How do you find out what bugs are already submitted for the particular project? And how do you look after a bug yourself? If you can fix the bug, how do you tell somebody that you know how to fix it so you can close a particular bug? How does it interact with other projects? This one is often neglected, but it's quite important. Very few free software projects are completely standalone. Almost none stand on their own without depending upon something else. And very often they contribute to something else. They're part of like a web of free software, or they each help the other one. So there's documentation systems that help to compile and format the documentation for other projects. There's compilers, there's libraries, there's packaging managers, etc. They all help each other. So the interdependencies between projects is quite important to work out so you can understand how the project reacts with other projects and also deals with the releases of other projects. if your project depends upon some other library, and that library is released with a new version, should you depend upon the new version or not? But you've got to make that decision. If you depend upon the new version, then everyone using your package then has to upgrade that library as well. Now this is one that you will hit in the second lab. You're going to be looking at a set of 5 possible projects, and one of them, Stellarium, depends upon a very new version of the Qt library, and that leads to some difficulties in building the Stellarium project. So it's quite interesting that they've chosen to depend upon a bleeding edge latest release that isn't in any of the stable distributions yet. That's their choice, and they chose it probably because it has features that they want to use. But you need to understand how that relationship works between the project and other projects, so you can understand if you make a contribution, should you depend upon features of the dependent libraries that may only be in the latest ones? Or when you make a contribution, should you deliberately test your contribution with older versions of the libraries to make sure that your contribution will actually be useful to all the people who are trying to use the project? Okay? So, project structure. You might like to look at how the project is structured. So is there a project team? Is it part of some larger project? So there's a project team. What is a project team?
The people who are contributing.
Yeah, people who are contributing. Usually a project team is defined, I mean it's defined differently for different projects, but it's usually defined something along the lines of the project team are the people who have the ability to commit directly to the project. Right? In other words, they have the ability, they are trusted to write directly to the project without asking anyone else's permission and without getting assistance from someone else. Okay? That's a reasonable working definition of a project team. Some projects have other definitions, right? Some have sort of a hierarchy of team membership. Some don't have a team at all. In the Samba team, our definition is anyone who has commit access into our project can directly modify the code is part of our project team. And we went originally from a project just one person being the team, so everyone else had to contribute via them, to being a small group of people. Different projects have different ways of dealing with this. Some projects don't really have a team. Okay, is it part of a larger project? So is it like a subset of a project? For example, a lot of the GNOME projects are part of a larger effort called GNOME to create a complete desktop. That's the desktop environment that you're using here in this lab. And all of the little widgets around the desktop, the little calculator, the editor, these types of things are all part of this larger project called the GNOME project that's trying to create a complete usable desktop environment. But then there are individual projects within that look after each of those little tiny widgets, those little tiny applications that make up the whole. But there's a structure to the whole project, and there's a steering committee, and there's rules, etc. of the whole project, which mostly apply to individual projects as well. Okay? Does it have any corporate involvement? Some projects have a strong corporate involvement. Can anyone name one?
So OpenOffice.
OpenOffice, indeed. OpenOffice has a strong corporate involvement. Who's the corporate involvement? Sun Microsystems, right? So they bought OpenOffice, they bought what's called Star Office at the time from a company called Star Division in Germany. It was a proprietary application, then they released it as free software. But they've kept a fairly close eye on the project since releasing it, and they've got their own commercialized version of OpenOffice, which is Star Office, still called Star Office. And then OpenOffice is the open source variant, but most of the contributors to the project are working for Sun. But you can contribute if you're not working for Sun, it's just that most of the people on that particular project are on the payroll of Sun. And that gives the project a slightly different slant, a different flavour in development than a project that doesn't have any corporate involvement. And understanding that corporate involvement can be important when you're getting involved in the project. Otherwise, you might tread on toes if you say the wrong thing. So it's important to understand that. Okay, does it have any formal legal framework? Some projects have a formal framework. So they have if you want to contribute to the project, you have to sign a piece of paper. Sometimes you have to just sign a web form, right? Put an I agree and click OK in a web form. Other ones require you to sign something witnessed by a justice of the peace and that sort of thing. Each of those things usually comes from some historical event in the project that led them to a particular decision about the legal structure. And so that if you look into the history of the project, you can usually find there is some point in time where they decided we need this because of some legal event that happened. So that's happened in the Samba project, for example. We require personal, not corporate copyright because of some legal events that I'll be describing in one of the later lectures. Okay? So who makes the decisions? Who are the project leaders? Who decides what the direction of the project is? Is that formalised, or is it just whoever provides the patches? For many projects, it's just whoever provides the patches, that's the direction it goes. And so the project is in many ways like a random walk, you know, just stumbling along towards better code, which actually works surprisingly well. All right? There's a quote, I think Lena said this, that somebody was asking him for the roadmap and looking out ahead of what's going to happen to the Linux kernel. And he said that, I don't like looking too far ahead, or you tend to trip over what's in front of your feet. And that's a common attitude in the free software community. People in the free software community tend to try to deal with the immediate issues, what's right in front of your feet. What are the problems right now that people are hitting? Roadmaps are less common. Some projects have them. They're largely there to keep some of the corporate users of projects happy, to think that there's this thing called a roadmap. Of course, the roadmap is often just a fantasy, right? Because you're usually not paying any of the developers, so actually guaranteeing to get a particular feature by a particular time is almost always impossible. But very often, development happens faster than if you did have a corporate environment or a roadmap anyway, partly because of the motivation of the individuals. But you may end up going a different direction than what you originally planned. That's just how things work. It's a little bit chaotic. And so it is a bit of a random walk the projects. So when you see things like roadmaps and stuff for a free software project, take them with a grain of salt. It's fairly rare that they turn out to be accurate. Okay, so finally there's one of these sort of broad things. And this is some terminology that was made up by Eric Raymond. Is the project a cathedral project or a bazaar project? Right, not bizarre, bazaar. Okay, many of them are bizarre. So cathedral or bazaar, what does that mean? What's a cathedral project?
Highly structured with a small elite in control.
Right, small elite group of people actually doing the development typically, and often doing it behind closed doors. So cathedral projects are often projects where you have a small group of programmers who really know the subject matter well. They tend to do releases less frequently, and they tend to work among themselves furiously within a small group, and then every year or two say, here's the new version, you may all use it. It's like coming down out of their ivory tower and saying, here be blessed the new version, all right? So that's the sort of cathedral type thing, the priests in the cathedral doing the work. Other projects are more a bazaar style. What's a bazaar type of project development? How do you think it works? So it's basically anyone contributing patches all over the place all the time. And the project just, new releases happening very frequently, all of the development happening completely in the open, no particular list of people who do the development. The most extreme example would be the Linux kernel, which is very much bazaar style development, where you see, in any day you see hundreds of people posting to the mailing list, posting hundreds of patches in all sorts of areas, and no particular obvious sense of organisation around it. That tends to be bazaar style development. Yeah?
How do you get involved in the cathedral style development? It seems more elitist to me.
It often is. You still can get involved. What tends to happen is it tends to be by invitation. So you demonstrate your capability by contributing a whole lot of work, based on the last release, a year ago's release. You say, here's a new feature, here's this, and eventually the maintainers think, gosh, that person's making a really good contribution, let's bring him into the fold. Let's bring him into the cathedral, right? Anoint him as a priest. Okay? That tends to be how it happens. Sometimes there might be a corporate involvement in the project, and it means that the priests are the ones who work for the company, right? Sometimes it's based on, they all knew each other at high school and they were good friends and played in a band together, right? It could be virtually anything. But both free software projects can be either cathedral or bazaar. Historically, originally free software projects tend to be more cathedral-like and less bazaar-like. Why do you think that was?
There weren't so many people who knew how to do it.
Yeah, that's certainly true. Yeah. So think about the communications mechanisms. The free software movement really started in the 80s or so. How many of you used the internet in the 80s? Yeah? It was fairly primitive, right? UUCP was what ruled at the time. interactive conversations and things were much harder. Free software development tended to be done by small groups of people who were closely linked to each other in some way, often working in the same lab or working within an area where they had good communications between them. And that stayed on for quite a while. It was also believed that it was, by many people, thought it was the only way of doing complex software. A lot of people thought that trying to do something as complex as a whole operating system with a chaotic development process was bizarre. Imagine if you tried to build, I don't know, something complex like a battleship and just have thousands of people who all come and oh, let's do this, oh, let's do that. If somebody wanders past and, hey, an anchor looks good there, right? How would it be? I mean, the battleship would probably sink, right? It probably wouldn't work. It'd be complete chaos. And so it was assumed that building software was like that. It was assumed that you can only build software, really complex software, right, by having teams of architects, very organised, highly specialised, but it was shown not to be the case. Very good quality software, very, very complex software can be built through the bazaars type method where everyone just comes along and says, let's add an anchor here, right? It's a real testament to the malleability of software that's possible. And so the example that coined this phrase was the Linux kernel, because operating system kernels had always previously been developed in a cathedral style. Small groups of tightly knit people all doing the development of the kernel. And the Linux kernel development model demonstrated that no, you can have everyone has a go type method with very, very frequent releases, and you can end up with rapid development and very good quality. So it demonstrated that it can work. And that was a huge surprise to a lot of people. And so that paper, the Cathedral Bazaar paper by ESR, was basically a reaction to that huge surprise. No one thought it would work, and it did. And it seems to work better than cathedral building in many cases. Right? It produces better software faster. And that was a real surprise. People are still trying to understand exactly why that works. Why isn't it chaos? Why isn't it like building a battleship? Why doesn't it sink? Okay, so making contact. So when you get, you've decided on what project you want to work on and you want to start making some contact with the project. So first of all, do your homework. Don't ask questions that are already answered on the website. So make sure you've read the Asking Smart Questions FAQ that I gave you as some background reading. Right? So make sure that you don't ask the obvious dumb questions that everyone's already asked before. Right? Make sure you read the mailing list for a while to understand the project, to see how other people are interacting with it, to discover the norms of the culture. They may not be written down anywhere. Sometimes they are written down. If they are, great, read it, but don't necessarily believe it. Read the mailing list anyway and make sure that you start to understand the culture by observing how people actually work in this project in practice. When you do start asking questions, make sure you check that nobody's asked that question before. Do a search, right? Include enough information for an answer to be possible. Tell them what type of system you have, what operating system you're running on, what type of CPU you have, anything that might be relevant. Don't overload them with pages of information. It can be quite tricky to get the right balance, to give them just enough information that they can answer it sensibly without including 10 pages of system information that they'll just delete the mail because it's too long, they couldn't be bothered reading it. Right? You've got to get the question to the right level, and Asking Smart Questions talks about that to some degree. Don't be demanding. One of the lectures we're going to talk on is FOSS culture, and I'll give some examples of emails that I've received and some colleagues of mine have received over the years. Sometimes you get amazingly demanding emails from FOSS users. What happens to them?
Bitbucket.
They get deleted.
Yeah.
Right? If somebody sends me I demand you fix this right away, I'll just delete it. I don't want to deal with that. I don't want to deal with the aggro. Right? So if I was a proprietary software company, I'd probably, swallow my pride and, say, oh, yes, sir, no, sir, 3 bags full, sir. Well, in the free software project, nope, delete it. Okay, so be nice to people, be considerate, but don't be too, the free software community tends to be terse and technical and to the point. It doesn't tend to be slathering, lots and lots of pleases and thank yous everywhere. That again will turn people off. That's why reading them out of this first, understanding the culture is important. You've got to try and fit in a little bit. And it can be quite difficult if you're not from the same cultural background as the people who are working on the project. Getting that level can be quite difficult. You'll usually find most projects have some degree of tolerance. Okay, show that you're put some effort into finding the answer yourself. So if you've got a question, make sure, show that, in your email that you've thought a bit about how to find the answer. You've tried a bit. You haven't just, as the first thing, tried to ask them to solve it for you, right? I've occasionally got emails and things like, I'm trying to install Samba on Solaris. Please tell me how to do it. Just delete that mail. There's a whole website on how to do that. If they bothered doing a Google search for Samba Solaris, they would have found it. If they don't know how to do a Google search, bad luck, right? I haven't got enough time to deal with those types of things. Remember I mentioned in the last lecture that free software is unusual because there's a direct connection between the developers and the users. You're able to talk directly to the developers. Well, what does that imply when you've got 300,000 users?
Developers have finite time resources.
That's right. In the proprietary software world, if they've got 300,000 users, they'll hire a significant number of people to help them. And they will hire those people who are there to help out the users. In the case of a free software project, they won't. Which means if you're trying to talk to half a dozen developers, there's 300,000 users, and they all ask stupid questions, they're just going to get deleted. Now what they may do is put up the answer on the website in something called an FAQ, frequently asked questions, right? But they probably won't answer your individual questions. Some will, and some won't. And it depends partly on their mood, or on how much time they've got, all sorts of things. I used to have my phone number up for Samba. Anyone could ring me and ask a Samba question, right? You can guess that I eventually took that down. And I started getting a few too many questions. And some people still do. Some projects have their phone number up. They're really enthused about the project. They say, they answer every question that comes along. The younger the project is, the more you'll tend to get enthusiastic answers from the developers because they've got less users. When you've got hundreds of thousands of users, you can't answer all their questions. And you will get a lot of dumb questions from users. Okay. So, contributing a patch. This next lab, you're going to have an exercise where you're expected to contribute a patch, but not to the project directly. We're going to be doing a simulation of it within the lab. You're going to be contributing patches to each other, right? You can, of course, continue the ATPS lab. We can spill over this lab into the third lab as well. That's fine. I know you didn't all finish up the ATPS lab, but the aim of the second lab work is to pick one of 5 projects and then build it, much the same as ATPS, and solve the build problems, and then to create a patch, some sort of change. And it can be a trivial change. You can changing a name, changing some constant, something absolutely trivial, and then you are supposed to submit a patch for that change to the COMP8440 mailing list. So you're all going to be submitting a change for one of these 5 projects to that mailing list, and then you should look for somebody else who's in the class who has submitted a change to the same project to the mailing list, and you have to accept or reject their patch and explain why, try and apply their patch, and so you are going to be the maintainer. So you're both a developer and a maintainer, playing both roles in this little sort of experiment. Okay? So when you're doing the patch, these are the things that we're going to be watching out for. Because of course Bob and I are also on this mailing list. We'll be watching. If you don't follow the rules, we'll come and, I don't know, rap you on the head with a GNU manual or something. So, research first. What patch format is wanted for the project? Right, and I've got some guidelines up on the course website on patch formatting. Against what version of the code? You don't send patches against outdated versions of the code. How much explanation is wanted? Right, do you put in 6 pages explaining your 1-line patch? Or do you put in 3 lines? In some cases, 6 pages is needed if it's a really, really complex change to that line and very, very subtle. But it's extremely rare that that's the case. So we're going to have a look at a few examples in a minute. Are tests and documentation for your change expected? Depends on your change. Sometimes the changes wouldn't need additional tests or documentation. The existing documentation and testing will be fine. Sometimes you should be submitting testing and documentation changes as well. Is there some sort of developer guide? Does the project have a guide on its website or in its documentation that says how to do development, how to contribute patches? Right? Many projects do. Have a look on the mailing list. What happened to previous patches? Find the ones where the person got flamed. Everyone know what a flame is? Right? A flame is where an abusive email reply, typically, usually email, that says that somebody's doing the wrong thing. Okay, and it can be quite embarrassing to be flamed sometimes, It'll happen. Everyone's been flamed. I've been flamed plenty of times in my career in the FOSS world. Heaps of flames. Some of them I keep because they're classics. They're lovely flames. And they're really well worded and quite funny. And some of them I don't keep because they're less flattering. Anyway, so have a look at what happened with other patches, see how they were reacted to, then try to do something that will be reacted to well. Testing. Make sure the patch works before you send it, right? Of course, if you choose a nice trivial patch, hopefully that'll be easy. Make sure it doesn't break anything else. Make sure it's portable. You know, did you make a change that now depends upon a Intel CPU? Did you make a change that depends upon running on Ubuntu? Right? You need to think about those types of things. That requires software engineering knowledge specific to the language that the program is written in. Be calm and patient. It may take a lot of time to get a patch integrated. Hopefully, all of you will be able to get one patch each way during the lab today and tomorrow morning. But if not, then Bob and I can reply to some of the patches. Because of course, there might be 3 people working on a project, and of course, with an odd number, it won't quite work. So we might also contribute some patches and reply to some. Okay. So VLC, so what I was going to look at now is the VLC project. Now, we're actually a little low on time, running a bit behind time. The schedule...
It's actually lunchtime now.
It's lunchtime now, right. So what I was going to do, we'll break for lunch, we'll just do it very briefly on this. I was going to bring up the Video LAN project, VLC. Remember we did the example project 8PS. And 8PS I deliberately chose as a project that has a number of significant problems with this documentation and website to show you some of the issues you may run into. Okay? VLC is the opposite. VLC is an incredibly well-organised project, right? And it's a very good example of a project that has gone out of its way to do all of the right things, to have comprehensive development pages, guides on how to use it, guides on how to develop, guides on how to contribute, guides on how to use their source code management system, screenshots. It does things like, it says how many downloads have happened in the last second. It even, on some of the download pages, it automatically works out what platform you're on and offers you just the download for your platform. All sorts of lovely things like that. So if you want to see an example, I was planning in the last part of this lecture to go through this website and show you all the lovely features of it, but I'm keeping you from lunch, so we might skip that. But I do suggest that at some stage when you've got time to look through the VLC site, because it is a very good example of an extremely well organised and extremely active project that has gone all the way in all the right areas of free software development. Okay, so we'll break for lunch, and after lunch we've got another lecture, and then the final lab, and in that final lab for the day, you'll be doing the patch and using source code management systems and starting to send patches to each other. Right, so enjoy your lunch.